This video is to go along with your test review for your test during week 1.5, and I'm going to work some of the problems with you on this video to hopefully help you to study, and then you are expected to complete this test review on your own for the ones that I don't work. Okay, so I think what I'm going to do is probably work the evens on the top several sections, and then I'll pick a few at the bottom also. Let me see if I can make this a little bit bigger. Okay, I think that's good. So in these top sections, the original instructions were solve these using like bases. And I'm going to solve some of these using like bases because it's actually easier than trying to go to Desmos and graph everything. So if I solve them using like bases, you can do it that way, or you can use Desmos. It's totally up to you which method you use. So number 2, for example, because the 3's are the same, the bases are alike, I'm just going to solve this using like bases instead of typing it into Desmos. If the bases are the same, then what you can do is mark out the bases and set the exponents up equal to each other and then just solve for x. So I'm just going to set up 5 minus x equals x minus 7. And then when I'm going to subtract x over here, and that gives me negative 2x. And then when I subtract 5 here, I get equals 12. No, excuse me, negative 12. And then divide by negative 2, x equals 6. So if you went over to Desmos and you graph that, you should get x equals 6 unless I did something wrong. To me, this is just faster than even going over to Desmos and typing it in. So for number 4, again, it's so easy to change the 36 to 6 squared. I'm just going to go ahead and do that. Now, what I want you to understand is 6 to the x power times 6 to the 8th power. This equals 6 to the x plus 8. So if you have two things with the same base and they're multiplied times each other, you add those exponents together. And then 36 is 6 squared. So then I can set this up because the bases are the same. X plus 8 equals 2. So x would equal negative 6. And if you put that in Desmos, you should get the same thing that I got. Let's look at number 6. Okay, so for number 6, I'm going to enter this in Desmos. I think it's easier to do that. Let me find my Desmos. Here we go. Let me make this. All right, so this was number 6, and I need to back out of what I had over here. Okay, so if you remember, on one line we put the left side of the equals. So we put what's right here on one line, and then we put what's here on the second line. So on the first line, I'm going to enter 4, and then I need to hit Shift 6, and then I'm going to use parentheses to keep all of this in the exponent. Plus 1 in the exponent, just to make sure it doesn't come back down to the other line. Okay, and then here I just need to enter 1 and then /16, and that will enter that 1/16 exactly like I want it to. So I'm going to zoom in here just to make sure I'm actually on the point where they intersect, which is right here. So my answer is x equals negative 1. If I had done using like bases, I would have changed this 1/16 to 4 to the negative 2. And then 3x plus 1 would equal negative 2. I would subtract 1 over here. 3x equals negative 3. X equals negative 1. Just to show you that you should get the same thing whether you solve it using like bases or whether you type it into Desmos. Okay, that's number 7. Let's find number 8. Okay, so number 8 is log functions, and I am going to use Desmos to do these, just to review with you how to type in the log functions also. Okay, so if you have a log, and remember, one line is going to be this right here, and this doesn't have a base, so the base that's implied is 10, and we don't even need to type that in. I'll show you where to find that log function. Okay, so come back over to Desmos. The first line is going to go here, log x. And so I'm going to go to my keyboard, functions, miscellaneous, and then I don't need to use the log base A because it's log base 10, so I just use the log key, and then I put an X here. Okay, so that's log X. And then for the next line, same thing, it's log base 10, so I can just use the log key. And then in parentheses, it's 3x plus 14. Sorry, I entered equals 14 the first time, so I fixed this and entered plus 14. Here's the interesting thing about this one. This is another common base or like base problem where if you have both of them are just log base 10, you can set it up x equals 3x plus 14. Here's the problem. When I subtract 3x over here, I get negative 2x equals 14, x equals negative 7. You can't have a negative when you solve for these. So what happens is you get this negative 7 and then you have to like plug it back in or whatever. But if you graph it, what you can see is that there's actually, I mean, it doesn't matter how far I zoom out. Like I've zoomed out to 20,000 and I can click and there's no point that shows up. So these actually do not intersect at all. And so my answer is no solution on this one. So if you zoom out to like that far and you click on that line and there's still nothing showing up, then just put no solution because that's most likely the answer. Okay, let's look at number 10. Now this one does have like bases. I could set this up, but then I better remember how to factor to be able to find it because it's going to probably turn out to be 2 solutions. So easier to come over here and graph it. Go to my keyboard, go to functions. This is log base 4, so I need to use that log base A so I can get the 4 in the subscript. And then my in parentheses is x, and to get that exponent up there, hit shift 6 and then squared. Hit tab to bring it back down so you can close your parentheses. And then the second part, log base A, it's going to be a 4. And then in parentheses 10 minus 3x. Let's see if we end up with 2 solutions. I believe I already see 2 places that these 2 graphs intersect. One is right here at negative 5 and the other one's right here at 2. So those are my 2 solutions. So you can write it like that, or you can use set notation, but do not put them in parentheses like that because that's an ordered pair and I will count that wrong. All right, number 12, it says rewrite using change of base and then evaluate. Now we did this on Tuesday, I think. And so what we did was we said, okay, if we have, and we want to evaluate this using a calculator, if we have something besides base 10, we can't put it in the calculator. So what we have to do is use that change of base formula and do log 16 and put that in parentheses divided by log 4. So we would use our calculator. Let me see if I can bring my calculator up. There it is. Okay, so I would just enter in my calculator, use the log key, log 16, close the parentheses, divided by log 4, and that's 2. Oh, yeah, okay. I didn't even look at it very carefully, but yeah, 4 to the second power is 16. That's what it's asking me. So the answer would be 2. Okay, and then did we have a 14? No, we just had 13. So again, let me show you what you'll enter in your calculator. You need to put in, and this number is the one that goes on top when you do the change of base. So it's log 7.59375, close parentheses, divided by log, and that is a 1.5, I think. So you put that in your calculator and see what you get, and round to 3 decimal places. So the next section on your test review says go to this IXL and get an 80 on that section. And this will be part of the test review grade. So we're going to go over there, if I can get it to work. Okay, so if you can't get it to work, highlight it, hit Control C, and then go to Chrome and hit Control V and go there. I don't know why the link won't work, but so we're going to work on a few of these. I need to bring up Desmos. So what we're doing is we're identifying whether these two functions are inverses of each other. And I'm not going to reteach all this. I'm just going to tell you that you need to go over to Desmos and go to your inverse function check that I showed you. I've shown you several times already in live lessons. And if you don't know what you're doing, then you can go to one of the live lessons and watch it, because obviously you weren't there that day. So I'm going to enter the negative 3x minus 9, and then the g of x is x plus 4. So obviously the purple doesn't coincide with the orange, so my answer would be no. So you're going to do this section, and again, if you don't know what I'm doing, then you need to go over to the live lessons and watch those instead of trying to guess or trying to figure out what I'm doing here. If you've been at the live lessons, then you understand what I'm doing. So let's jump a level and maybe do one more. All right, so f of x is x cubed plus 1, so I'm going to hit x, shift 6, and then my cubed, and then tab plus 1. And g of x is a cube root, so I need to go down here to functions and go to this nth root, put a 3 there for the cube root, and then under the radical is x plus 4. These aren't exponential functions, but it's still good practice for inverse functions. So again, the purple and the orange don't coincide, so the answer is no. All right, so that's all I'm going to do on that. Going back over to the test review, your next section, I have actually provided the answers for you. I'm going to do a couple of these just to show you how to enter some of this stuff in Desmos, because they're a little bit complicated. So let's look at this one. So what I'm going to do is I'm going to enter this on one line, and then I'm going to enter this on the other line and see if they intersect. And it looks like they do. It looks like I should get this answer, which is a huge answer. So let's look at let's see how that's going to look on Desmos. I'm going to go back. We'll just go back to a blank graph. Okay. All right, so for the first part, I'm going to enter log base 8, which is down here, functions, miscellaneous. I need log base A, so I can put the 8 in there. But all of this stuff is going to go over that 2.3, so I need to start out with parentheses. And then this is going to be an X, and that's in parentheses, and then I'm just going to click on the outside of the parentheses, plus 21.4. Okay, then I'm going to close my parentheses, and then when I hit the / button, it puts all of that in the numerator, which is what I need. And then 2.3 goes in the denominator, so there's that graph. And the other one is just f of x equals 11. So I know that it's going to be 3,000 something. So I can just zoom out until I see that point, and it was actually there for me, 3,326.986, and that is exactly what we get when we practice this one. I mainly put these on here so that you could practice putting these in Desmos, because some of them are a little bit complicated with the exponents and the fractions and everything. Let's look at this next one right here. So on the left side of the equals is this, and it does have an E in it. If you remember, you can just type in a lowercase e and it will calculate that number for you. So let's take this out. Okay, and then, all right, so we're going to enter 2, and then there is a times button. You can put the times button in and it'll put the little dot in. Okay, so E is just lowercase e. Shift 6, and then I'm going to use parentheses just to make sure all this stays in the exponent. Negative x, and that's plus 14, and then use parentheses there again. Okay, and then the other side is 38. Let's look at what the answer is supposed to be. The answer is supposed to be 11, so I need to zoom way in here so I can see where they intersect. All right, so it's right there. And x equals 11.056, and that's actually what we got on here, so that checks out. Let's do one more. Let's do number 8 because it has a natural log. So I'll show you where that is. So on the one line, I'm going to enter, it's not number 8, sorry, I said it was number 8, it's 8 times that, and then on the other line, I'll enter negative 24. I'm gonna go ahead and do the negative 24 first because it's easy. And so up here, I need to go to my functions again. I'm going to go ahead and put the 8 and then times, okay, and then go to functions, and you see the ln, that means natural log, it's right there, just enter ln, and then in parentheses 2x minus 5. Okay, so let's see what the answer is supposed to be. It should be 2.525, and if we click right here where they intersect, it is 2.525. Okay, so that's all I'm going to do. There's no way for me to prove that you did these down here at the bottom. I'm not going to, require you to show me a screenshot or anything like that. So you practice those if you want. There may be some of those very similar on the test on Friday. But I do want to see up here where you actually get the answer. So put the answer up there and then do this IXL right here. And your test will be on, well, it'll be on Canvas, but it'll be an Edpuzzle test just like the other ones have been.